Hello students, this is lecture number 6. I can say L6 and principle of mathematical induction chapter. Okay, I think in the previous class we had done up to 15 problems. Today I am taking 16th one. So 16th one is what here, prove that 1 plus 3 by 1 plus 3 by 1, it's a first bracket. Second bracket 1 plus 5 by 4. Third bracket 1 plus 7 by 9. Plus so on. 1 bracket, 2 bracket, 3 bracket, so on. How many bracket? I have n brackets. You see. So on up to n brackets. So nth bracket has what? 1 plus bracket of 2n plus 1 divided by n square is equal to n plus 1 whole square. This given statement is true for all natural numbers. He is asking that prove this given statement is true for all natural numbers. The thing is, here compared to previous problem, all problems are sum of the terms. You see, it's the main difference. Here there is no sum of the terms, there is no middle case, there is no plus in between. So in between two brackets there is no addition. Means I can say these are the multiplication terms. Previous problems are all addition term. This is a multiplication because first bracket, second bracket, third bracket, these are multiplied. How many bracket we have? N bracket. In the previous problem we have n terms, addition of 1 plus 2 plus 3 plus so on plus n. Means we are proving for n plus 1 term. Means we have to add on both the sides. You see all problems are addition, but here this problem 16th one, and I will take another one problem that is same as multiplication. So here I can say n brackets multiplied, means I need to prove for another one extra bracket, means I need to show that k plus 1 term. K plus 1 term means here instead of adding term we will multiply. Keep in mind, because these given terms are multiplied, means first bracket, second bracket, third bracket, so on nth bracket, means I can say n terms multiplied. This value is equal to n plus 1 whole square. For example, n is equal to 1. N is equal to 1 means 1 plus 3 by 1 is a 4. So you will substitute here n is equal to 1, you will get 4. Means obviously these LHS is always equal to RHS. The thing is we have to prove here using all the natural number. Instead of doing all the natural number, we have the principle. Using that principle we will say n is equal to 1, n is equal to k, n is equal to k plus 1. What is the thing different here? Nothing. Instead of giving addition, this is a multiplication terms. In the third step, what we need to multiply here? We have to multiply this thing expressing n plus, that n place is a k plus 1. Means what we have to multiply here? Instead of addition, we have to multiply, because these are the multiplication terms. Because these are the product form. Means what is a multiplication term? Yes, 1 plus 2, n place we are taking k plus 1, yes, k plus 1 plus 1 divided by n place k plus 1 whole square. This we have to multiply. Means what we have to multiply? 1 plus 2 into k, 2k plus 2 into 1, 2. This bracket plus 1. Means I can express this multiplied 2 into k, 2k plus 2 plus 1 I kept, divided by what we have? K plus 1 whole square. What is the multiplication term? 1 plus 2k, 2 plus 1, 3, divided by k plus 1 whole square. This is the multiplication term. In third step, what we have to multiply? In third step we have to multiply this term. In the previous case only we are deciding on the basis of nth term. Here also we are deciding on the basis of nth term. I replaced n is a k plus 1. Simplified form is this. You have to multiply. Previous all problems we added. Every time we are adding, because those all are addition of the term, sum of the terms. This is not sum of the term, this is a product of the term. For that reason you have to multiply. Why we are multiplying? Because the given this statement is product of the terms in the case of LHS. Means this is the multiplication term we decided. What we need to prove? In the place of n, I need k plus 1 whole square. I need to prove this. Very simple. N place I need to show k plus 1. N place I need to show k plus 1. So k plus 1 is like n plus 1 whole square, means we need to prove k plus 1 whole square. Instead of getting this k plus 1 you will get k plus 2. K plus 2 can be written as 1 plus 1, so then you have to prove. This is the thing. In the case of multiplication, this is how to multiply. Ultimately, how to express RHS is a k plus 1 whole square. This is the thing. I will solve it. This I took roughly. So I will take, right now, let, as usual procedure, let P of n be the given statement. Let P of n be the what? Given statement. 16th one. Let P of n be the given statement. You can write, let P of n be the given statement. What is the step 1? Step 1. Put n is equal to 1. When you are taking n is equal to 1, what is the first term? First term is here, first bracket. I can say LHS is equal to, means this what? P of n is a 1. Yes. What is the LHS? LHS is equal to first bracket 1 plus 3 by 1. What is 1 plus 3 by 1? 1 plus 3 by 1 is a 3 only. Is it 4? Yes. What is the LHS? 4. What is RHS? RHS is equal to, what is RHS? N plus 1 whole square. N plus 1 whole square means here n plus 1 whole square. What is n? N we are taking 1. 1 plus 1 whole square is what? 2 square is a 4. Yes. What we have? LHS is equal to RHS, means I can say LHS is equal to RHS, means that P of 1 is true. P of 1 is true. P of 1 is true here also. Step 2. Step 2. Nothing. It is as usual same, only the thing is first bracket I took. First bracket we proved. And step 2. Put n is equal to k. Wherever n is there, you replace k. Now step 2 is what? P of k. Yes. This one. 1 plus 3 by 1. Yes. What is the second? 1 plus 5 by 4. Yes. 1 plus 7 by 9. So on. Don't write plus in between because it is dot. Dot means it is a multiplication of the terms. N place you have to replace k. What is 1 plus n? N is what? 2k. 2k plus 1 whole divided by n place is what? K square. Is it? N is replaced by k is equal to n is what? K plus 1 whole square. You call it is equation 1. Is it like same? You see this statement and this statement are both are same. First bracket, second bracket, third bracket. So on last bracket is a n replaced by 1 plus 2n plus 1. Here 2k plus 1. Divided by n square there, here k square. RHS side n plus 1 whole square, here k plus 1 whole square. This is step 2. Means what it implies that you can say P of k is true. P of k is true. This proved. Now I will go for step 3. Step 3. Listen here. Step 2 is clear. As usual, step 3 is the main. In the case of step 3, what is the special here? Special is nothing. We have to multiply. Instead of saying we have to add, I think up to 15 problem I said we have to add. I am not saying here we have to add. We have to multiply the term. Which term? This simplified term. This you can say. I can say to prove P of k plus 1 is true, we have to multiply which term? We have to multiply this one. This nth term we can take roughly. You can write here roughly what it is. 1 plus 2 n is what? K plus 1. N jaginaga k plus 1 tagori. Plus 1, this is the thing, see that, divided by k plus 1 whole square. Means what required thing? 1 plus 2 into k, 2k, plus 2 into 1, 2, plus 1 already, divided by k plus 1 whole square. What we have to? 1 plus 2k, 2 plus 1, 3, divided by k plus 1 whole square. This is the multiplication term that I took roughly. So you can write in your corner of the notebook. This will be roughly I am taking this. I will multiply. Then I will rub this and I will calculate. Which term we have to multiply? This one. We have to multiply 1 plus 2k plus 3 divided by k plus 1 whole square on both the side of equation 1. On both the side of equation 1. So is it? This is roughly. If you want, you can write in your rough paper. Okay. This you have to decide. I will rub this because I need space to simplify. We have to multiply on both the side. We have to multiply on both the side of equation 1. What we are multiplying? That we can obtain term. What is the obtained term here? See that. Yeah. Now, P of k plus 1. Yes. Equation 1 is what? This one. 1 plus 3 by 1. 1 plus 3 by 1. 1 plus 5 by 4. 1 plus 7 by 9. Dot dot dot. It's a multiplication. 1 plus 2k plus 1 whole divided by k square. Which you are multiplying? We are multiplying this term LHS side and as well as RHS side. 1 plus 2k plus 3 divided by k plus 1 whole square. This is LHS side. RHS side. What is RHS side already? K plus 1 whole square. K plus 1 whole square. What we are multiplying? We are multiplying 1 plus 2k plus 3 whole divided by k plus 1 whole square. See there. What I did here? I multiplied this term and this term LHS as well as RHS side. Both the side I multiplied this. Now the thing is, okay, simplify. I want to simplify. After simplify, I should get n place is a k plus 1. So now k plus 1, yes, k plus 1 whole square. What is the LCM? LCM is k plus 1 whole square. You multiply this one. 1 into k plus 1 whole square plus 2k plus 3 whole divided by k plus 1 whole square. Can I say this cancel and this cancel? What remains? Yes. This remains. K plus 1 whole square can be written as a plus b whole square formula. A plus b whole square formula is what? A square plus b square plus 2ab. Means k square plus 1 square. 1 square is what? 1 plus 2ab. 2 into k, 2k plus this 2k plus 3. Listen here. This get cancelled. K plus 1 whole square is a square plus b square plus 2ab. I wrote k square plus 1 square plus 2k. 2k I kept plus 3 I kept. This I can write still. K plus k square. Yes, k square. 2k plus 2k. How many k? 4k. Yes, 4k. Plus 3 plus 1 square. 3 plus 1 square is 3 plus 1. 3 plus 1 is how much? 4. This is the thing. I will express here. Still. I will continue. What k square? K square. I have k square. This can I make it as factors? 4 means 4 means 2 into 2. Can I say like 4k can be written as 4k can be written as 2k plus 2k plus 4. What happened? K common means what remains? K. K square means 1k remains plus. Here what happened? K goes, remains what? 2 plus 2 common from these two. 2 common means 2 k plus 2 2s are 4. 1 2 goes means now k plus 2 is common. K plus 2 into remains what? k plus 2 in the square bracket again, k plus 2. K plus 2 into k plus 2 is the same. Bracket into bracket is bracket square. K plus 2 into k plus 2 is a k plus 2 whole square. K plus 2 whole square. But what we need, n place I need k plus 1 whole square. But I got k plus 2 whole square. What we will do now? Is it any problem? There is no problem. We got k plus 2 whole square. But I need k plus 1 whole square. K plus 1 whole square means can I write plus 2? K plus 2. Plus 2 can be written as 1 plus 1. Sure. I can write it is like k plus 2. This 2 can be written as 1 plus 1. What happens? See? Is it like n plus 1 whole square? It is proved. It implies that I can say P of k plus 1 is true. It implies that hence P of n is true. P of n is true for all n belongs to natural numbers. It is true for all natural numbers. Nothing it is. You say n is equal to 1, LHS equal to RHS 4. N is equal to k, wherever n is there k. To prove P of k plus 1 is true, we have to multiply, because these are multiplication, because this is a product term. So I multiplied on the basis of n. N is replaced by 2k plus 2 plus 1 is a 2k plus 3 divided by n place is a k plus 1 whole square on both the side of equation, and multiplied LHS as well as RHS. LHS keep because we have k plus 1 terms. Now RHS simplify till to get this answer in the form of n plus 1 whole square. N is replaced by k plus 1 whole square. Therefore, the given statement is proved. Means that this problem is proved for all natural numbers. Okay, copy this. Now 17th, prove that this is again it is like product form. What I did previous problem, it is like same. I think you can try also. I think without following me, you can do it in your notebook, this problem. As usual, nothing. You have to multiply and you have to prove n places a k plus 1. What is the given problem? 1 plus 1 by 1, 1 plus 1 by 2, second bracket, third bracket, 1 plus 1 by 3, third bracket, plus so on. How many brackets we have? First bracket, second bracket, third bracket, so on. How many brackets? N brackets. Is equal to n plus 1 for all n belongs to capital N. The thing is, again we have multiplication, means I can say product of the terms. How many terms multiplied here? How many terms are there? How many brackets are there? I can say n brackets, n plus 1. So means RHS side is n plus 1, means LHS is equal to RHS. Always the given statements are equal only. They are compulsory given or equal. The thing is, when it is equal, definitely it will satisfy. But we have to show that these statements are true for all natural numbers using principle of mathematical induction. What it is? What is the addition multiplication term here? Multiplication term is depend upon this. What is the multiplication term? Yes. What is 1 plus 1 divided by n place we are substituting k plus 1. It's very simple. This is the multiplication term. Nothing. n place naga k plus 1 substitute madini ashte. Previous problem daga n place naga k plus 1 substitute ಮಾಡಿದ ನಂತರ simplify ಮಾಡಿದ್ರೆ you will get one particular term that you have to multiply. Nothing. It is very simple. What we need to prove? ಏನು ಪ್ರೂವ್ ಮಾಡಬೇಕ್ರಿ? n ಪ್ಲೇಸ್ ನಾಗ k plus 1 ಪ್ರೂವ್ ಮಾಡಬೇಕು. n ಪ್ಲೇಸ್ ನಾಗ ಏನು ಪ್ರೂವ್ ಮಾಡಬೇಕು? k plus 1 ಇಲ್ಲಿ ಬರ್ತದೆ. ಸೊ ನಿಮ್ಗೆ ಏನು ಪ್ರೂವ್ ಮಾಡಬೇಕಾದ್ರೆ k plus 1 like. It's a very simple. I think you can try. Now you can try this. I will solve this. While solving, you have to follow or you have to solve yourself. Okay? Right. As usual procedure. Let P of n be the given statement. Let P of n be the given statement. You say, let P of n be the given statement. Let P of n be the given statement. Now, step 1. Step 1. Put n is equal to 1. When n is equal to 1, what is the first term here? The first bracket. I can say P of 1. P of 1 is LHS. LHS is the first bracket. What is 1 plus 1 by 1? 1 by 1 is what? 1 by 1 is 1 only. 1 plus 1 only. What happens? 1 plus 1 is 2. What is RHS? RHS is equal to n plus 1. n plus 1 other. See, n plus 1. What we need to prove? n is a 1. n we need to prove n is a 1 plus 1. What happened? 2. It implies that what happened? LHS is equal to RHS. What we are saying? P of 1 is 2. This is very simple, huh? This is very simple compared to all previous problems. Okay, this is about first step. We proved n is equal to 1 place. Then I will go for n is equal to k. Yes. Step 2. Step 2. Put n is equal to k. What is p of k? Yes. What is the first term? 1 plus 1 by 1. What is second bracket? 1 plus 1 by 2. What is third bracket? 1 plus 1 by 3. Plus so on. Plus sorry. This dot. Dot. Multiplied how many times? 1 plus 1 by k is equal to n is what? K plus 1. You call it as equation 1. What happened? P of k is true. P of k is true because it is look like same as in the given. It looks like same in the given. So P of k is true. Step 3. To prove P of k plus 1 is true, we have to multiply which multiplication? This one. See, what is the rough case? 1 plus 1 by n. n is what? K plus 1. This you have to multiply. n place naga k plus 1 haki simplify ಮಾಡಬೇಕು. But in this problem it is not need not necessary to simplify. 1 plus 1 by n is what? 1 plus 1 by k plus 1. This you have to multiply on both the side of equation 1. What is the equation 1? Equation 1 is here. Where this? P of k is always equation 1. Now P of k means what we are proving? P of k plus 1. This one. What we have? 1 plus 1 by 1. 1 plus 1 by 2. 1 plus 1 by 3. Dot. How many? 1 plus 1 by k. What we are multiplying? We are multiplying this bracket. See. 1 plus 1 by k plus 1. The thing is, you observe another thing. K terms, k plus 1 terms. First bracket, 2. Second bracket, 3. Third bracket, k bracket, k plus 1 bracket. Because we are proving for which term? K plus 1. K plus 1 means we need k plus 1 terms. Here, k plus 1 products. So, RHS, it's equal. It's equal to what? We have k plus 1. K plus 1. What we are multiplying? This thing. What we are multiplying? 1 plus 1 by k plus 1. Yes. Now, this we need to simplify and we have to prove like n place is a k plus 1. And then we will prove n jaginaga k plus 1 barbeku. It's very simple. Now I will take LCM in this case. 1 niga k plus 1 multiply maadu. So k plus 1 ada illi 1 ಗೆ k plus 1 multiply ಮಾಡಿದ್ರೆ k plus 1 ಬಂತು ಪ್ಲಸ್ ಇದು 1 ಅಲ್ಲ as it is divided by k plus 1 ಉಳಿತದೆ. Yes. Yeah. What happens? See, k plus 1 cancel. Both are same. Numerator as well as denominator. Whenever numerator and denominator quantities are same, you can cancel it. K plus 1. Yes. K plus 1 I need. Don't add 1 plus 1. After adding again 2 can be written as 1 plus 1. Don't do that. Already we have. In this case we got it. So I can say here what happened. K plus 1 got it. K plus 1 got it. N place is what? K plus 1 is a like n plus 1. n is replaced by k plus 1 means what happened? This you can say P of k, if k plus 1 is also true, means that I can say hence the given statement is true for all n belongs to capital N, means that for all natural numbers. It's a very easy, nothing here. Simplification is very simple on the basis of this. These two problems are product case. Remaining is not a product. Previous 15 problems are addition. This 16th one and 17th one product case. These two. And then after this I will take some statements. According to that statements we will prove. So it is like first 10 problems are addition case. Second problems are addition but in the denominator case. And third like is only two product. And then last problems are statements. He will give us some statements. According to that statement we have to prove. We will see those problems. Okay, complete this. Now 18th problem. This one is a mathematical statement. So what we had done previous, all are mathematical statement, but they are, I can say, series. They are sum of the term, and previous two problems are a product of the terms. Here there is no product, there is no what? There is no addition. Means the given statement is what? This is, I can say, prove that rule of exponent. Prove that the rule of exponent AB whole to the power n is equal to A to the power n, B to the power n. I think in the case of rule of exponent we are saying if it is ABC whole to the power n, A to the power n, B to the power n, C to the power n, means according to this you can calculate easily in the case of power. AB whole to the power n is A to the power n, B to the power n using PMI. PMI is what? It is not Prime Minister of India. It is what? Principle of mathematical induction. Don't get confused. This is PMI is a principle of mathematical induction. For all n belongs to capital N, means this exponent rule is also true for all natural numbers. Means he is asking that this mathematical statement is true for all natural numbers. This is very simple, nothing here. I will go for step 1. In the case of n is equal to 1, I need to prove AB is equal to AB. Whatever you will get LHS and RHS, that you have to. And in the case of step 2, put n is equal to k. Where n is there, you have to prove n is a k. Nothing. There also you will get P of k is true. And then step 3. Step 3, put n is equal to k plus 1. Take LHS and prove RHS. Here it is not necessary to multiply the term. It is not necessary to add the term. Previous 15 problems are we are adding one term with both LHS and RHS. But here it is not necessary because it is not sum of the term, it is not product of the term, it is one of the exponent form. In the case of exponent form, only you take n is a k plus 1, take LHS, prove RHS. Means you have to show that actually in the case of step 3 we have to prove AB whole to the power k plus 1. Using this I need to prove A to the power k plus 1, B to the power k plus 1. If it is n place is k plus 1. Here n is a k plus 1. N is a k plus 1. N is a k plus 1. It is proved. Here it is not like addition, multiplication. So this is directly you can prove. Okay, very simple it is. Now we will see one by one. What is asking? Prove the rule of exponent AB whole to the power n is equal to A to the power n, B to the power n by using PMI. We have come across so many times AB whole to the power n is A to the power n, B to the power n. This is a mathematical statement. This mathematical statement we are proving by using principle of mathematical induction. I will say let solution case. Let whatever it is, I said in mathematics, whatever it is, we are saying it is a one of the P of n. P of n is nothing but mathematical statement. Given this writings can be written as P of n is a mathematical statement. Let P of n be the given statement. Listen here. Given statement. What is P of n? P of n is AB whole to the power n is equal to a to the power n, b to the power n. Listen to me. Now I will take step 1. Step 1, put n is equal to 1, n place naga 1 substitute madri. What is a p of n is a 1? Yes. What is LHS? LHS is equal to ab whole to the power n. N place naga ಏನು ಹಾಕ್ಲತ್ತೀರಿ? N place I am replacing ab whole to the power 1. Means ab whole to the power 1 is ab. Yes. What is RHS? RHS is equal to a to the power n, b to the power n. What we are taking n? A to the power 1, b to the power 1. A to the power 1 is a a, b to the power 1 is a b. A to the power nothing means 1, or else a to the power n, a only. A to the power n, b to the power 1, c to the power n. Anything to the power n is that same thing. So a to the power n is a, b to the power n. Is it ab is equal to ab? Means I can say it implies that LHS is equal to RHS. LHS is equal to RHS. It implies that I can say P of K is true. Sorry, P of 1 is true. P of 1 is true. P of 1 is true. Okay. Step 1 we did. I will take first step 2. This is okay. AB is equal to AB. This is proved. Step 2. Put n is equal to k. Here ಇದ್ದಲ್ಲಿ k substitute ಮಾಡ್ರಿ. What is P of k? Yes, P of k is this. You take colon. AB whole to the power k is equal to a to the power k, b to the power k. N place n is a k. N k, n k, replace. If you want, you can call this equation 1. Is it like exactly as same given? ab whole to the power n adalli illi k ada, illi a to the power k ada, alli n ada, illi b to the power k, there also n. Means n is replaced by k. Means can I say that is it given this and this are same means both are equal? LHS equal to RHS means I can say that P of k is again proved, not again proved, every time it is proved. P of k is true. P of k is true. Now step 3. In this case I am not saying to prove that we have to substitute, or you can say I will put directly. Put n is equal to k plus 1 in the given statement. To prove P of k plus 1, to prove P of k plus 1 is true, put n is equal to k plus 1. I think this is very simple. In the given statement you have to say put n is equal to k plus 1. Otherwise you can say that step 3. To prove P of k plus 1 is true, put n is equal to k plus 1. Put n is equal to k plus 1 in P of n. Okay. P of n is what? A statement. If you want to say specifically, you can say that put n is equal to k plus 1 in P of n. In P of n means P of n is where? P of n is this. AB whole to the power n is equal to a to the power n. Means what we have? P of k plus 1 n. Yes. Now, what is a AB whole to the power n is what? K plus 1. AB whole to the power n is k plus 1. So means what we need to prove? AB whole to the power means actually AB whole to the power we need to prove a to the power k, b to the power k, k plus 1, k plus 1. But don't consider that. I will take LHS. What is the LHS? LHS is AB whole to the power k plus 1. AB whole to the power k plus 1 means can I write AB whole to the power k plus 1 can be written as AB whole to the power k. Bases are same, powers you can split, or you can say bases are same, powers you can add, or if you want powers you can split. AB whole to the power k plus 1 can be written as AB whole to the power k and AB whole to the power 1. Are you getting? AB, this is direct. A means we need ab whole to the power k plus 1 is equal to a to the power k plus 1 b to the power k plus 1 means it is not proved. This is directly I got, but this if you want to prove, you take LHS ab whole to the power k plus 1 ತಗೊಂಡು simplify ಮಾಡಿ prove ಮಾಡಬೇಕು. ab whole to the power k plus 1, ab whole to the power k plus 1. I can write ab whole to the power k separate, ab whole to the power 1. What is ab whole to the power k? ab whole to the power k is what? ab whole to the power k is ab whole to the power k is a to the power k, b to the power k. Is it? I can say ab whole to the power k is a to the power k, b to the power k. Using this, ab whole to the power k can be written as a to the power k, b to the power k using equation 1. And a to the ab whole to the power 1 is what? A to the power 1, b to the power 1. So I will write a one side, a one side I will write, and I will write b one side. Means I can write like a to the power k into a to the power 1. Yes. Then b to the power k, because bases are same, b to the power k, and then b. See what I did, a to the power k, a I collected here, then b are same, b to the power k, b I collected here. So means LCM, LCM, the bases a to the power k, a to the power a, means both the bases are same, means can I add powers, means I can say a to the power k plus 1, b to the power these two, and this one, b to the power k plus 1. Is it proved? No. A to the power k plus 1, b to the power k plus 1. Means LHS is equal to what we got? RHS. Means it implies that what I can say, p of k plus 1 is also true. Is also true. It implies that you can say hence given p of n is true for all natural numbers. Proved. It's a very simple problem, and this also exam point of view, I think you will get in the exam also, because I think it is a focused problem. So it is a very simple problem, nothing. ab whole to the power n is equal to a to the power n, b to the power n is equal to 1. I replaced where you got n, ab is equal to ab, LHS, RHS. Step 2, n is a k, and to prove p of k plus 1, n is equal to k plus 1, ab whole to the power k plus 1 is equal to a to the power k plus 1, b. This is not proved, this I got direct. Then taking LHS, ab whole to the power k plus 1, ab whole to the power k plus 1 can be written as ab whole to the power k, ab whole to the power 1, because bases are same, powers you can add, or if you want you can split the power. ab whole to the power k, ab, then ab whole to the power k is a to the power k, b to the power k, ab, a collected one side, b collected one side, a to the power k plus 1, b to the power k plus 1. Therefore you can say this statement is true. This is proved. These are 3 problems today I am taking. So in the next class I will take remaining problems. Okay.